Okay, hi guys, welcome back to QBT. Thanks for joining us. Today is a follow-up video from our last video, which was on this equation, how force is equal to the change in momentum over time. But this video, I want to go over this equation in a little bit more detail, give you some higher content, higher GCSE content, IGCSE content, triple physics content, and I want to give you an example of how we might use this equation in an example question that you might get in one of your exams. Okay, so we know that force is equal to the change in momentum over time, but what I wanted to discuss today is the relationship that force and time have in this equation. Okay, and effectively what it is what we call an inversely proportionate relationship. Okay, and that's the opposite of a direct relationship. It's the opposite of directly proportionate. Okay, the best way that I can explain this is actually to explain to you what directly proportionate is first. Okay, now directly proportionate means as one goes up, the other goes up by the same amount, right? So if I times one number by 2, the other one also gets multiplied by 2. If I divide one value by 2, the other one is also divided by 2. Okay, they have a linear relationship. Inverse proportionality is the complete opposite of that. Okay, and what it means effectively is if I multiply a number by 2, its pair is divided by 2, right? So the same thing is happening but in reverse, and we see that in this relationship, right? So an example here, I like to use simple numbers to explain this. We would say that 5 newtons is equal to 10 on momentum divided by 2, right? We've got 5 and we've got 2. 5 and 2. But then if I double time, right, we've got 10 divided by 4, which is 2.5, which is half of our original value. So by doubling time, I have halved my force. Why is this important? Why am I telling you this? Because you might get a question that asks you to calculate the force just from a time value. It won't give you mass, it won't give you velocity, it won't give you momentum. But you will have to know the relationship between the two in order to answer the question. So that's why I'm telling you this, higher content. But how do we actually apply this equation in full? When I've got all the variables, how does that work? Why don't you take a look at this video where I explain it to you. Okay, so let's look at this equation in a little bit more detail. We've got force is equal to our change in momentum over time. Okay, now how might we apply this equation? How might we actually use this in a question? Well, let's say that I had a question. I'm just gonna make one up for you. So a collision occurs during a traffic accident, and the person collides with their steering wheel with a force of approximately 50 newtons. And the individual has a mass of say 70 kilograms, and because of his seatbelt, the time it takes for him to collide with his steering wheel is increased, and the total time for his collision to occur is about 0.4 seconds. Can you calculate the velocity that this person was traveling at before he collided with his steering wheel? Okay, so how do we approach this question? And the way that I like to do any question in physics is I need to know what do I have, i.e. here, this is the have, right? And then this is the have not, right? This is the mystery. And when you're doing your question, you should always read the question and write down all the variables that you have, and then you will be left with the variable that you do not have. And the one that you don't have needs to become the subject of your equation, okay? So now we need to look into rearranging this equation. And we can do that by breaking it down a little bit. So we know that force is equal to the change in momentum over time, and we know that momentum is mass times velocity divided by time, okay? Then if I multiply across by time, that means that force times time is equal to m times v, right? Mass times velocity. And now I want to get velocity on its own, so I divide through by mass. Okay, and that means that velocity is equal to force times time divided by mass. Then I simply take my numbers and I plug them in, and I'm going to do it with you on my calculator. So I would do 50 newtons multiplied by 0.4 seconds divided by mass of 70 kilos. Okay, and I would get 2/7 and 0.29, and that's rounded to 2 decimal places. Okay, 0.29, and that would be meters per second, right? Okay, so not a terribly realistic number, but you know, the time was super quick. So you know, this is our answer, right? And when you're doing these sorts of questions, you really need to just write down what you have, write down what you don't have, and then make that your subject. Go from here to here, like that. Okay, start your rearranging process, and then plug in your numbers appropriately. And make sure that your units are in their standardized forms, okay? So if this is not in kilograms, then you need to convert it. And if this is not in seconds, then you also need to convert it. Okay, but that's how we can apply the equation to a real example question. All right, I hope you guys learn from this, and I hope it helps you understand the equation in more detail. Okay, so that was my explanation, and I hope that it helped you. I hope it helped you understand how the equation works in real life examples, in an exam question that you might have. But yeah, that's the video for today. I hope that you learned something, and if you have any questions, then again, please post it in the comments. If you have any suggestions for future videos, then again, your comments are really welcome. In the meantime, please like and subscribe. It really helps us, really supports us, helps the channel get out to more people. And yeah, in the meantime, stay quantum, and I'll see you next time. Bye guys.